We are recording from beautiful Austria. Welcome.
Water is the basis of all life. Depending on the use, a certain water quality is required. That is why it is essential to measure it. There are 3 dimensions to water quality: a physical, a chemical, and a microbiological dimension. Currently, there are only sensors to measure the physical and the chemical dimension. Therefore, only these can be used for process control. But process control is crucial to ensure the quality, efficiency, and safety of any process. Because there are no sensors for microbiological quality, this quality is unknown, although it affects health within minutes. It is still tested using traditional methods that take days to deliver a result and are unsuitable for process control. Because of this, all water-related applications are carried out in 2D, as only physical and chemical dimensions of water quality are available for process control. In order to meet quality standards for the microbiological dimension, oversized processes and overdosing disinfectants are necessary. This affects all water treatment processes from drinking water to wastewater. If process feedback is missing, a process cannot be controlled and therefore is not efficient, not sustainable, and not safe. The shift from 2D to 3D process control requires fully automated, rapid microbiological methods in order to provide the microbiological dimension of water quality for process feedback, process control, and early warning.
Now it's time for a special topic for this deep dive, and a topic which was special enough for us to get one guest. Björn, can you introduce our guest?
Yeah, today we have Wolfgang Vogl from Vienna Water Monitoring Solution here with us. Welcome, Wolfgang, better known as the ColiMinder product. Maybe you have heard this a little bit, because today we want to talk about online bacteria measurement. That's what we are going to talk today about. And I have to admit, as I came the first time to that topic, it reminds me a little bit to my times after university. I was writing my diploma, because you know what you would say ages ago, but be careful, we have Wolfgang here today.
You do the jokes yourself today. That's great.
The point was, at this time, I was in a waterwork like this one here, right? And there was an old UV disinfection system, and we wanted to replace that. And we said, hey, we can take a UF membrane, which works as well. It can disinfect. We all know 99%, 99, whatever, depends on the membrane element. But there was one authority who had clearly denied every solution we came up with, and they said clearly, you have to have a UV. And there was the water authorities who said clearly no. And I think we have here a little bit the same situation, because we have to send the water, depends a little bit on how big the water work is, to a lab. On the other hand, Wolfgang, you can monitor all the bacteria every 15 minutes. So isn't there a discrepancy at the moment?
It's like always, a new technology needs some time to be adopted. And of course, people in water business are busy, as you know. They are busy with their work they do it every day. There is not much space reserved for picking up new technologies. And at the same time, it's a very important topic. So,
but who's Who let
the dogs out?
who's a little bit the party pooper? Is it really the authorities, or is it the operator with a 2 days training who is saying, well, I have no clue about that, I will stick to the lab solution? Who's the party pooper here?
the fact that the drinking water is such an important topic, people take care about the quality. They don't change things easily. And that's understandable. It just takes some time. And especially if it's about biological contamination, they tend to stick with what they do up to now. And that's also what's given in the regulations. They need to do it anyway. But if they get our technology in addition to that, and then they learn. As soon as they get a real-time feedback on what's going on within their processes, and they automatically learn. They can't refuse to learn. It's just by looking what's there. I always use that example with the car. If you have a car with a black windshield and only a back mirror, you see, when you're driving, you see what you hit yesterday or day before yesterday. That's because the lab results take a day. At least.
Let's take a step back.
Yeah.
What's the problem we try to solve here? What is really this thing which keeps operators up at night, which we might be able to solve with online monitoring?
If you think about water quality, it's three dimensions to it. There's a physical dimension, a chemical, and a microbiologic dimension. A physical and chemical, there are a lot of sensors, and they're installed everywhere you see them. Concerning microbiology, the system runs without feedback and without control. That's the topic. You have big treatment systems running without process feedback in the dimension of microbial quality. That's the fact.
I give you an example. Over the last 10 years, it happened to me twice that the fire departments drove through our village where I live with a loudspeaker saying, "Hey, people, listen to us. You have to boil your water because it's contaminated.
Sir, there's something in the water.
We have an issue. We have a serious issue. We will solve that. But today, we have to boil. And tomorrow again, and maybe the day after, we will inform you if that is solved." That happens, really. And I'm living in Germany. I'm not living in the, somewhere.
Yeah, that's what I say. You're living in Germany. That's the reason why. But
That exactly happens, right?
how did they know that water was of bad quality?
Well, in principle, if I understand that right, depends on the regulation, how big you are. For instance, this waterwork here has to monitor twice a year bacteria.
Okay, so
They take a sample and send it to the lab.
So what you're telling me is that regulation is saying that every 6 months is fine, and you're trying to sell me the point that every 15 minutes shall be much better.
Yeah.
Why would I take that step? I'm so in a peaceful position with my every 6 months.
Of course, in a waterwork like here, it's hard to sell a ColiMinder to them if there's not an additional benefit. For instance, one benefit would be you have an activated carbon filter here. After activated carbon, the law in Austria requires UV because there might be some bacteria building up in the activated carbon, and then you need a UV. And as it takes too long to get the lab results, if there is contamination, so there's a preventive need to use UV. That's the law. If we would try to get the thing more efficient and more maybe sustainable, only use disinfection if required, we could have a ColiMinder here monitoring the outcome of the filter quality, and if there is contamination, then we add the disinfection.
If you are free from regulation, everybody has to be responsible for the water quality, but then you're free to achieve it however you like. An alternative to the system today where you have activated carbon, UV, and testing twice a year would be activated carbon, testing continuously, and as soon as you detect that you need disinfection, you switch the UV lamp and
that would be one use case.
Makes sense. But what's the magic? Why are you able to measure something every 15 minutes if the standard method takes 1 day in a Petri dish?
3 days. Come on, it takes
days?
3 days. Well, I mean, you have to take a sample. You have to transport it there. You have to work on that.
Yeah.
It takes
Incubation time takes
1 to 3 days. Let's settle that one. Okay.
Yeah, it's an important thing. It's about life. So the goal is there are bacteria, they are too small, you can't see them, so you need to make them visible somehow. And that's what this traditional method does. It uses the fact that they proliferate, put it into ideal conditions, and wait until they multiply to a number or they become visible. That's the standard method. And then there is an agreement. Okay, we take this agar, and then after 24 hours we count. That's an agreement. If they would count after 36 hours, it would be also comparable results, but 24 hours seems to be the minimum to get reliable, reproducible results.
That's the traditional way.
That's a traditional way. You told me that we have to gather the information some minutes ago during my editorial. You said we have to gather all the information.
I'm just
Here we get information with the ColiMinder. We know exactly the amount.
Wait. My question is by which magic?
The traditional uses the fact that proliferation makes it visible, and what we do in the ColiMinder, what the ColiMinder measurement approaches is an enzyme assay. Enzymes are the catalysts of every metabolic activity. We need them because our metabolism needs enzymes to catalyze this process and to feed us with energy. And the same happens for all other living creatures or organisms, plants and algae and yeast and mold and bacteria, and everybody who is alive needs to get energy and therefore have a metabolic activity. And there are always enzymes involved, and we measure enzymes. The ColiMinder is measured with enzyme concentration or enzymatic activity. And that's a direct reflection of the energetic turnover of this life.
So you use these enzymes as a proxy to evaluate the bacterial presence.
Yeah. If you break it down to very simple, you could say we measure the energetic turnover of our target organisms.
So that means you start up and you probably have to calibrate. So you take like the traditional approach and you put your numbers next to the traditional approach, and then you can from there on extrapolate.
As the perspective is different, the culture-based approach has a different view on bacteria, as our approach, the energetic or enzymatic approach, is a different view. Always, if you have two different views, we need to match because they see things a little bit different. And therefore, if we have a waterworks like this, we would recommend the customer to do parallel testing for a while in order to get the match. But basically, the enzymatic activity is a scientifically defined value. In contrary to the standard CFU things, enzymatic activity is scientifically defined. So you could set a maximum level of enzymatic activity for drinking water, E. coli specific beta-glucuronidase, for instance.
Bingo! Good.
And it would be the same around the globe, and it could be measured with whatever method because it's scientifically defined. That's a great advantage.
You say we could, so that means that today in the rules, there is no
rule for it.
Okay, so the rule doesn't exist, but it could exist. And if it existed, you wouldn't be the only ones to be able to measure. There would be other ways to measure. So it's not like something which would be binding to your ColiMinder. It's something which would be really open.
Exactly. It's an approach. The enzymatic measurement approach is an approach. It's used, for instance, there are some standards like ISO standard for pasteurization of milk. They are based on alkaline phosphatase activity. So there is a standard that's used in the standard to measure the pasteurization efficiency of milk products.
Isn't that we discussed that. We discussed that the operator here has a 2-day training, more or less, right? What we discussed right now sounds really scientific. How can we help the operator really that he understand that? He get a lot of data. How can we ensure with a 2-day training that it helps him? I think, isn't that the barrier we have to break through? That people with the 2-day training, that they understand that we can make their life easier? Isn't that really the approach with each and every technology we bring to the market?
Sure. It helps only if you're able to influence something. If you're not able to influence something, if you're just monitoring your waterwork and you have nothing at hand to influence anything in there, it's only an alarm. That might also be helpful because then they don't have to drive around the village and asking everybody to boil the water because they know in advance that something's going wrong. So then it would be only for a while, and then they would get specialists in to solve the problem. But if the people in the waterworks, if it's in a point of the waterworks where they really influence the process and maybe take decisions, what flocculation agent, what intensity, what
chemical dosage. Think about chemical dosage. How you can reduce this consumption.
When to backwash.
Yeah, exactly.
When to
energy. Energy.
You can monitor after the filter. As soon as you see, okay, now it's going up, then you can do a few tests, and after a few times, okay, at that level of enzymatic activity after the filter is the best way. We should stop here and backwash, and then proceed with our treatment.
Actually, it goes along what we were discussing in your editorial, which is you have a source of data which gives you a new view on your system, which you could feed into machine learning, for instance, to use some buzzwords. And then you don't care if the operator is trained for 2 days. He's not the one operating. The machine is operating. He's just watching that the machine does right.
Exactly.
Yeah.
Exactly.
So my question is, we are here in a drinking water treatment plant, and it makes sense we discuss municipal because we're into the municipality, but the municipality is really limited by regulations. If someone was to now measure the enzymatic activity, they would still have to do the old-fashioned way, and they would still have to use UV all the time. So the added value to them is limited as long as law doesn't allow you to bring more added value. But there's a green field which uses twice more water in the world, which is twice, 3 times, 4 times, 5 times more under pressure when it comes to water, and that's the industrial sector. And there, I guess, you don't have a regulation which tells industrial people when they're inside the facility that if they're using activated carbon, they have to put UV. They have to be efficient, and it's only for their process.
Yeah.
So that's the Eldorado for you.
Yeah, that's the ideal customer. The ideal customer is the customer that produces water or even circular economy, reuse water, reuse even more for its own purposes, because then the quality is really the focus and the efficiency is really the focus, and there's no regulator needed because they want to use it themselves and they need to have it in a good quality and safe, and they don't want to spoil their production of whatever they produce. So they want to have a good quality and they are looking after it and take every bit of information to guarantee that. And that's the best customer. You absolutely right.
Can you have some KPIs on that? Like you have an example of, I don't know, in dairy, I don't know what would be the best industry for you, where you can say, thanks to the installation of an enzymatic measurement, they were able to reduce the usage of that chemical by so and so much, or reduce their energy needs because they could shut down the disinfection when it wasn't needed. Do you have these kind of figures?
Not yet really full-scale operational systems where you can say, okay, that was it before, and then they implemented the ColiMinder, and then it gets that much better.
It's obvious.
This is what it is.
It is obvious that you say that you save a lot of chemicals, that you save a lot of energy for the backwash. You can save also the energy for all the pumps to control the pumps, because even the pumps, they have an influence on the biological growth and things like that. So it is obvious.
You say not yet. We have in our set since the beginning of the show, maybe you noticed, we have a ColiMinder in the background. How much of that is a prototype? How much is a finalized product? And how do you roll it out?
It is not a prototype anymore.
Okay.
The core unit for the measurement system itself is stayed the same since is more than 10 years. So it's really, its robustness and its quality is proven. What we have at the moment is this system which is used from ultra pure water until very heavy contaminated wastewater. So the same machine. We diversified in terms of target organisms because the enzymatic approach allows to measure specific organisms. Very important. We can stick with the indicator organism concept. That's the most important thing. So we have diversified concerning target organisms, but not concerning machines. That is the next steps. We are actually working on a model specifically designed for ultra pure water, because that's a very interesting topic. There's a lot of interest from the industries, pharmaceutical, but also even more clean water. We improve, let's say, or adopt the concept to the specific needs of specific applications.
I mean, I'm coming from the point. I saw this the first time and I was thinking, damn, I'm a membrane guy. And the biggest issue we have with membrane is what? Fouling. So, and fouling is exactly what we can not prevent, but what we can measure.
Sure.
And then if we can measure this in an exactly and specific way, we can prevent longer lifetime, OPEX reduction, and say all of this. And I was thinking, thank God. I mean, that is the industry was waiting for, right?
I have a big problem with the silver bullets. You lost me at we can cover from ultra pure to wastewater. Now, if you can pick one field, which is the one where you add the most value today, which one is it?
I would say drinking water upwards. Drinking water, pharmaceutical, ultra pure, because the product is the most expensive there.
Yeah,
the value,
it's the highest value. Yeah,
the value per liter, and that's of course always the decisioning parameter is what is the value of what we save with this, or efficiency we increase and the output the product. How valuable is it? That's
So when you were in the ultra pure environment, are you in the ultra pure water loop, or are you in the makeup part of the water?
All parts. Of course, you have to start, and the better you start, the less energy you need until you are at the level of pureness that you want. And of course, starting with the good first step is the best way to start.
The reason why I'm asking is that if you're in the ultra pure water loop, which targets stuff in the parts per million, parts per billion, parts per quadrillion sometimes, if you want to measure that, you have to go for GCMS, LCMS, which is, again, offline machinery done in the lab, costs $500,000 one piece. So if you can bring a solution to complement, supplement, even replace that, then you have an incredible value proposition. Is that what you're aiming for?
That's at least something that seems to be feasible and where we're working on. So we have a very good technology, which we know very good. And as in every technology, if you know what limits your quality, then you are able to develop. Only if you know the point that limits your quality at the moment, and then you can take it from there and can improve that. And then you always have to be fully aware about your technology and what are the limiting factors, what are the possibilities, where's the chance to go, where's the chance to improve. And that's what we are constantly doing.
A little bit back, I mean, we have the regulation which is saying, well, we have to measure every 6 months, and you are doing every 15 minutes. But there are other, suppliers who can do this in hours, in minutes, in seconds. So what is the right amount here to measure this? I mean, how many data we really need? Isn't that enough? Let's say twice a year to every 15 minutes, or do we need it really data every minute, every second, every hour? What is it? I mean, aren't we a little bit overwhelming the operator again?
Let me just answer, because that's the type of questions I'm raising on my podcast where I get this answer, which is, it depends. No, the real answer.
No, yeah, it depends on the dynamics of the system. What we recommend to our customers, for instance, you install a ColiMinder and then you'll have it run on full speed for 1 week to evaluate the dynamics of your process. And from that point, you get a timeline like this, and then you can decide and say, okay, I want to capture at least these peaks. So in order to capture them, in case they occur, we need that frequency. So you evaluate doing a high-speed measurement, you evaluate the dynamics, and then you take the decision. It's always cost against benefit. And then you take the decision, okay, it's okay for me to measure once per hour, or I need to measure 30 minutes, or maybe it's a slow system and once every 2 hours would be okay as well, because I can capture everything that might happen in the process.
Let me ask also a kind of podcast question from your podcast. I mean, you are now since 2016 in the market.
16, yeah.
16. So that means 7 years if I good at math. So what is the biggest and coolest project you have with the ColiMinder? I mean, I know that you are more or less everywhere in the world. So we are here in this little Austria, in a very little town, and we have here a company who is deployed all over the world, more or less.
Well, you pick the one you want to answer to him. Let me crack a secret. We have Isabel running around, going through the cameras, taking some pictures. And I heard when she brought us to here, I heard the words of Haute Paris, I heard Hong Kong, I heard many places. So looking forward if there's something even cooler than what we already heard. Didn't want to influence you, but...
Don't be shy.
The coolest projects are those, I think, where we learn the most. And this was, for instance, a project done by the Water Group in Belgium, where they put different technology in parallel in a water distribution hub and have them measure the same sample. That was really a cool project.
One-to-one comparison between different technologies.
Yeah, they put the different technologies for rapid microbiological measurements, they put it next to each other and have them measure the same sample. In order, the question of this scientific study was, how do microbial water quality measurement systems and how do they respond to contamination in practice? That is a really cool thing, because we also learn, we don't know, we don't have the other technologies in our lab to compare or to learn. And I'm sure that every approach has its advantage and every approach has its shortcomings and limitation. As soon as you know that, you can compose a process where you use every technology and every part according to its strengths. And if there is a weakness, you might find something that...
So it helped you to improve also the ColiMinder?
It's improved.
He's scientific. He's clearly scientific. So I'm pretty sure if we would ask Isabel, she would say, hey, maybe Hong Kong or maybe the other project. Wolfgang is one of the guys who always wants to improve the technology.
Not only our technology. It's the same applies, of course, for every process. If you do a water treatment for the city of Hong Kong, for instance, and you get the watering from here, and then you need certain steps to achieve the quality you require, then it's good to know the strength and the shortcomings and the limitations of the process steps you have, because the most efficient way to produce the best quality is the best way to do it. So you need to know, and then you combine technology that fits everything so that you don't have any risky unknowns.
I have a question on that. My question is the following: is when you mentioned this comparison done by the Water Group, what I hear is that you're not alone in that market. And that is usually excellent news, because that means there's a market. If you're alone, yeah, it's great to be alone in the desert.
Or you found the blue ocean. Come on.
We don't want to restart that conversation, Björn. Not again. We had that conversation.
Blue ocean, red ocean, and we should have it again because I will convince you about the blue ocean.
If there's no product, there's no market. So, and then you have to build up the market anyway, and they help us. All the competitors help us building the market.
Exactly. How do you go with those competitors? Is it like you convince together, for instance, regulators that they should allow your approach, or are you really fighting against each other?
I wouldn't see it as a fight. There is definitely competition, and everybody wants to get into specific applications. And of course, everybody tries to improve the technology and to prove that the technology works for certain applications. It's an application by application race. I'm convinced that one of the main advantages of our technology is that we are able to measure specific organisms. And there's always this buzz about pathogens. Everybody wants pathogens, and we are measuring pathogens. And in fact, most of technologies don't measure pathogens. They measure indicators. And that's a good concept. That's a very wise concept. We can't measure 27 pathogens, having one machine for every pathogen, and then you run more.
And maybe that's new coming.
So the pathogen measurement devices then you supply to your customer doesn't make sense. So this indicator organism concept is extremely important. And this is why I'm so fascinated with our technology, because we can stick with the indicator organism. We can measure E. coli as fecal indicator. And that's great because this is the main hazard for cities or for agglomerations of people. If this is not separated, the wastewater and the drinking water, then you get epidemics and people die.
I have a final question for both of you. I mean, I started with my example from 15 years back with regulation, UV and UF and things like that. When do you think such online monitoring will be implemented as a kind of standard compared to lab test? When do you think will this happen?
To me, we have to go...
Mystical ball. You have to
go one step higher. If you want that to become the norm, you need to have the ability to tap into the entire set of benefits. If you go to an approach where you have clever systems, like smart systems, which are almost operating themselves. I use the buzzwords and I hate the buzzwords. I don't like to speak about machine learning, artificial intelligence, but we have to take into account that given the silver wave, given the fact that qualified personnel won't be there in every plant in the future, and also given the fact that 75% of the costs of water treatment are in the network, so you would be better off if you had more smaller size distributed systems a bit everywhere. That all calls for clever, digitized and smart systems.
But you have to give an answer.
And these systems, they need data to work. And I would see that as the exact type of data that can bring tremendous value. How fast will this come to market? I think between 5 and 10 years horizon, I would expect it to arrive. Not in the next...
That the regulation will accept that? So 5 to 10 years?
The regulation accepts it. It recommends it as an...
Yeah, but it is not a standalone. And
risk... No, not for compliance, but,
exactly.
But for risk management. Yeah, the purpose.
My approach there is to think 20% of the water in the world is used by industrial players. Industrial players, if you need to cut somewhere, where do you cut? Do you cut on the 70% of agriculture? Then good luck telling to people that they can't eat. Do you cut on the 10% that people are drinking and using to wash at home? Good luck to tell them that they can't use that. So where do you cut? You cut on the 20%. So they will be put under pressure to reduce their water input. In the past, they would open their valve in the basement and they get drinking water from the city and then they flush it to the sewer. That was the old system. That system will vanish in the next decade, which means if you close the loop, what do? Do you hire dozens of water engineers and you run everything yourself? Or do you rely on technology giving you the right inputs to measure the right stuff at the right place and to feed the right models and the right brains? That is what is going to happen. And my crystal ball doesn't tell if ColiMinder is the one. From what we discussed, it sounds like...
But it's about the process to do it. It's about the process.
But yeah, it's a sum of things. And I think that's the right direction to go. Absolutely. Just my 2 cents.
So that means that the industry will be the role model that in the end the regulator will accept, even for the municipalities.
I would even see one day where people will open their tap and receive water, which is excess water from their neighbor industry. But that's a different topic.
Yeah, and I don't think that we have to, or it would be wise to get rid of a traditional method, a culture-based method. I wouldn't claim that it would be a good idea to completely get rid of that, but to find a good balance. If there are new measurement methods and combination with machine learning, with automation, and you have a lot of different sensors, and you can compose a good view, a quality view of what you have as a water. And then you say, okay, and in addition, we do this. We can reduce, for instance, the lab tests on from 2 per day to 1 per 2 days or whatever. It must be a complete picture. Everything must be covered. You need to be sure to supply your customer with high quality water. You want to do it highest efficiency, and you try to get everything you need for that. And then you evaluate the full picture and say, okay, and now we need some more here and some more there. And then that's fine. And maybe the new approach will not be that the regulator says you need to have a ColiMinder and you need.
No, but it is about the measurement procedure. That is how what we're talking about. So how do you measure that? Is a regulator, if they tell you have to send it to a lab twice a year, right? Or will they accept a measurement like this to say, okay, you got the data here? And I don't believe it will happen in 5 to 10 years, because the regulation process will just take too long. One day it will come. Hopefully we will live there at this time, hopefully, but it will come one day, clearly. But I don't think it will be so fast due to the fact the regulation.
If the industry so long picks it up,
doesn't matter.
You don't care about the drinking water sector. It's so small compared to...
If that is not your market, then for sure. But I mean, if it comes to the regulation perspective, from the lab perspective, it will take too long.
Didn't we just discuss that regulation will always be late and that states have a hard time to get up to speed with all of that? So let's start with the people which want to move, and it's not the municipal sector.
Yeah, absolutely. But it's a right approach.
Circular economy, especially reuse, and especially those people who use it for their own purpose, because they have an interest in efficiency. And
you get your own value. That's the best proof of concept. Well, I'd be excited to have this follow-up with you at the point where it's rolled out in the industry, at the point where we see it on another level. It might be 2 years, it might be 5 years, it might be, I don't know how long it takes, but that's an exciting journey you're on.
Definitely. Thank you very much.
Thank you, Wolfgang, for being with us.
Pleasure meeting you. Pleasure discussing. I would love to go on for hours,
Let's do that. Let's switch up the camera. Let's go on for hours.
Perfect. Thank you again, Wolfgang.
Thank you.
So you see, I think it was a good content today. I really loved the show. What did you think, Björn?
Sorry, I was just distracted again by your look, right?
Okay,
so come on. Please do me the favor. Please change the clothes next time.
Okay, you know what? Just because you asked for that, I dare you, for the at least 2 next shows, I'll be dressed like
Please
that.
not.
Okay. Tell it in the comments if you don't want to dress like that.
That is even more worse, and that we don't have any solution for the 2.2 billion. I was so disappointed by your top 3.
Actually, I'm not quite sure we don't have a solution, because what we discussed in the deep dive is exactly the direction where we shall be heading.
We measure everything from the online bank.
Yeah, and we go for the end we can influence, which is maybe not the municipal part, which is maybe not the part which is controlled by the states. If we already solve the industrial part of the equation, well, with the 120% water rules, we might even by extension solve the communities which don't have access to water. So maybe that's the way to take it. And if I were right now an industrial, I would partner and team up with the water industry, because that's the way out of this crisis.
You said partnering. I mean, I'm not sure that I want to partner with you anymore, because if you want to dress like this for the next 3 shows, come on.
I'll really dress like that.
Thank you very much. Thank you very much for...
I'll stay like that.
I'm so sorry about the dress, really. I'm so sorry. Come on, we have to talk about that.